Namaste everyone. Welcome back to the tutorial of image processing using Python. I am Dr. Atul, Assistant Professor from BIT Jhansi. This tutorial is continuation of the previous sessions. Therefore, it is recommended to watch previous session video before continuing to this. Before going further, let me discuss a short outline of this session. In this session, I will discuss about image restoration, degradation function and method of image restoration, restoration of noisy images, restoration of blurred images, image inpainting and how to remove objects that are unwanted from an image. And at last, I will discuss about important results and conclusion of this lecture. The process of image restoration is to recover the image that has been blurred, degraded by noise or some other problems. It is a very crucial step in the many image processing applications such as medical imaging, remote sensing, security, digital forensics, astronomy. However, choosing a appropriate method for restoration technique for different application domain may be different. So, it is not a trivial task. The restoration depends on the several factors such as type and level of degradation. The prior knowledge about the image is important in case of restoration, the desired output quality and computational resources available to us. The image restoration usually considers image formation process. It can be given by an equation Gx equal to n of fx into hx, where G is the observed or acquired image, f is the ideal or original image, h is the filter which explains the distortion caused, and image that is defined as spreading of data from a given pixel fx to a neighboring centered Gx and n is the stochastic process that explains the noise that is coming into the image. There is difference between image enhancement and image restoration. Both are not equal. How can we differentiate this? Image enhancement is based on the subjective method that improves the quality of image, whereas image restoration is objective method. The types of degradation. Degradation can be caused by various factors such as camera motion, lens blur, atmospheric turbulences, sensor noise, compression artifacts or intentional manipulation of the image. Depending on the type of degradation, different image restoration methods and algorithms may be more or less suitable and effective. For example, some methods may work well for deblurring images, while some other methods may be better for denoising techniques, or some other method of restoration may be better for image inpainting of the image. What is inpainting? I will explain later. So, to recover back our original image, a degradation model is required. A degradation model is a mathematical representation of relationship between the original image and the degraded image. A degradation model is a mathematical representation of relationship between original image and degraded image. It usually consists of two components. First component is called degradation function and second component is additive noise. The degradation function captures the effect of blur, effect of motion, effect of distortion, effect of noise, etc. or other factors that can alter the image content. That all comes in the degradation model. The noise term accounts for the random fluctuation in the image intensity due to sensor imperfections or transmission channel errors or some environmental effect over there. So, the noise can come from anywhere. It can be from the channel, it can be from environment, it can be from some fluctuations in the camera or somewhere. So, depending on the application and domain, different degradation models may be more suitable or realistic. For example, in medical imaging, a common degradation model is the convolutional model, where the degradation function is a linear filter that simulates the blurring effect of the imaging system. In remote sensing applications, a common model of degradation is multiplicative model. The degradation function or point spread function, let us say h of x, usually defines how the pixels are spreaded from the center to the neighboring pixels. Therefore, it is also called point spread function. These functions actually guide the restoration as a way to simulate the blur introduced by image acquisition system, considering that in image formation energy of a point is spreaded to surrounding pixels. This can be done using a Gaussian function. Gaussian function you already know, that is exponential function. So, h of x is equal to 1 upon sigma root 2 pi e to the power minus 1 by 2 x upon sigma square. How to do this in Python? So, if you are using Google Colab, you have to load the dependencies, then you have to mount the drive. After that, you can come to the modeling this all these things, whatever we are doing. So, parameter sigma in the Gaussian function is the dispersion, well, that have dispersion values. So, I am taking sigma equal to 0.3 and 0.1. You can take any value from 0 to 1, but for understanding purpose I am taking 0.3 and 0.1. Then we will plot these two and we will see the result. So, I have taken one variable x from minus 2 to 2 with the step size of 0.05, then sigma equal to 0.3, then Gaussian function, the mathematics of Gaussian function is modeled. Degradation model again for 0.1 sigma, again sigma taken as 0.1, then for this again I have written the same function and then I have used plotting command. So, plt dot plot x comma Gauss for first one and Gauss for then again plt dot plot for second one. This R is showing red color and B for blue color. Then I am also plt dot grid means it will turn on the grids in the plot. See here, there is one is very peaked result, another one is spreaded result. So, when sigma is equal to 0.1, then it is the less spread, means more spreaded. When sigma is increased, then it is less spread. But when you run this code, you will not work, because if you do not have added the libraries, then it will not work. So, you have to add all the libraries before using any function. In this code, I am using NumPy as NP, Matplotlib as PLT. Therefore, at least these two libraries need to be included. There was nothing related to images till now, otherwise you have to compulsorily mount the Google Drive to the Google Colab. Image restoration methods can be broadly classified into two types. First one is deterministic model, second one is probabilistic model. Deterministic model assumes that degradation model is known and fixed and use mathematical or physical principles to invert or solve the degradation equation. There are two main categories of deterministic model also, inverse filtering and deconvolution. Inverse filtering is simple and fast methods that applies to the inverse of the degradation function or the degraded image. Deconvolution is more advanced and robust method that uses iterative algorithm to estimate both the original image and the degradation function from the degraded image. Probabilistic models assume that degradation model is unknown or variable and use statistical and machine learning methods to estimate or learn the degradation parameters of the original image. Depending on the type of noise, a proper filter is to be selected so that noise can be removed from the image. Noise is removed with the help of a spatial filter either or the filters in frequency domain. There are some special methods used for the image degradation model. Applications of image restoration is very wide. but for our understanding purpose, let us take examples of noisy image. I will take a noisy image and try to restore it into the back. The method of restoration of noisy image goes with the help of filters. Filters I have discussed in the previous video. skimage library is available in the Python that have some functions for restoring noisy images. These functions use a model of image degradation and restoration process and try to estimate the original image from the noisy image using some optimization criteria or some prior knowledge. But the restoration process of noisy images is not limited to this function only. We can use some advanced methods for image restoration. Some examples of advanced image restoration methods are maximum likelihood method, Bayesian estimation method, blind deconvolution method, etc. etc. These methods can recover original image more accurately than simple filtering methods, but they may also require more computational resources, time and other special assumptions. Now let us go to the Python. I use Google Colab for programming in Python. You may use any environment, whatever you want, it does not matter, but to use images in Colab, Google Drive need to be mounted before accessing images, as we have to write 2 to 3 different commands for showing images. Therefore, I am making one function that can be used with the image variable and the title of the image. Usually there is comparison in our work, that what was the image before and what is the image after filtering or after doing some processing. Therefore, I am making one function for image comparison also. So, first function definition, this is define, def is for defining a function, show image. You can see that simple show image, showing an image is there. You have to pass the image variable and title of the image. And if you want to plot two images to compare, then I am taking one title fixed as original and second title I am taking from the input. And both will be plotted using the subplot command here. Two subplots have taken, one is left and one is in the right. Figure size is 10 by 8. We are going to consider the restoration of noisy images first. Here I am considering the image of human image, which I had considered in the last session from a standard database. This is from the database known as KDEF database, Karolinska Directed Emotional Faces, which is a set of 4900 images, but we need only one, so we will process one only. As we have already seen various methods of image denoising in the last two sessions of image filtering, just for one example I am considering total variation filtering. This is a new filter, and bilateral filter that you have already seen in the last video. Bilateral filtering I have already discussed. So, in this session I will just take it in brief about the total variation filter. It is based on the principle that signals with excessive and possibly spurious details have high total variation, that is the integral of the absolute image gradient is very high. According to this principle, reducing the total variation of the image of the signal subject to being a close match to the original signal removes the unwanted detail while preserving the important details such as edges of the image. The concept of this filter was given by the Rudin, Oser and Fatemi in 1992. Therefore, this filter is also known as ROF model. This noise removal technique has advantage over the simple technique such as linear smoothing, median filtering, therefore, which is reduce the noise at the time same way, but it is a little better method. Total variation denoising is effective for edge preserving, that it simultaneously preserves the edges and smoothens the noise. Now consider a 2D image. So the equation for this is given by summation ij y plus 1 minus yij yj plus 1 minus yij, which is isotropic and non-differentiable equation. Therefore, it is very difficult to minimize. Sometimes people take an isotropic version of this filter where the difference of yj plus 1 is taken at separate and I plus 1 is taken as separate. So, standard denoising function is available for this purpose in SK image library of the Python. So, I am considering the standard function here from SK image dot restoration import denoise TV Chamboli. Chamboli is one scientist who had given some modification in the total variation filter. So, I am applying this filter to the image human image, and you can see the result also here after this, that in the original image is more noisy as compared to the filtered image from the total variation. I have already discussed in the last session that bilateral filter is an advanced Gaussian filter with the modified weights. So, here I am not going in detail of it. If you are interested, you can watch my previous session video. I have given a detailed description of bilateral filter, but here for example I am using the standard function for this bilateral filter available in SK image library. You can import the bilateral filter from SK image dot restoration library, and then you can apply this to the image, and then you can see the comparison how it works for denoising or restoration in noisy image. The quality of denoising, it is important. Quality of denoising of images is a subjective method, therefore, it is very difficult to say it numerically which one is better. However, many researchers use many parameters and many matrices to quantify the quality of denoising. So, one common way to measure the quality of denoising is to use mean square error, which is the average of square differences between the denoised image and the noise free image. The lower the MSE, the better the denoising. However, this method requires a noise free image as a reference, which may not be available in some cases. Another way to measure the quality of denoising is to measure the signal to noise ratio, which is the ratio of mean of the noise free image to the mean of the noise. The higher the value of SNR, signal to noise ratio, the better the denoising. However, this is also require noise free image as a reference. Therefore, and also it is not sensitive many type of filters of denoising. Third way to measure the quality of denoising is to use peak signal to noise ratio, which is very much famous, which is a logarithmic scale of the MSE and also keeps into account the maximum possible value. The higher the value of PSNR, better the denoising. This method is often used in scientific paper of the image denoising. Fourth way is the mean absolute error, which is the absolute value, absolute differences of the denoised image and the noisy image. Lower the value of MAE, better the denoising. This is also more sensitive as compared to the MSE. Another method to measure the quality of denoising is structural similarity index, SSIM, universal quality index, UQI, and visual information fidelity, VTF. These are the advanced method which take account human perception also and visual quality also. So, in Python there are several libraries that can help you to do all these things, all the matrices, and calculate the quality of the denoised image. Here this is the code to calculate the mean square error and PSNR and SNR and all. For restoration of blurred image, it can be restored by using an image degradation model. For simplicity, Gaussian model of image degradation can be considered. So, Gaussian function you already know, h of x is equal to 1 upon sigma root 2 pi e to the power minus 1 by 2 x upon sigma whole square. 2D filter model. So, this this is a 1D equation, but the concept can be extended to 2D version. We have already seen Gaussian degradation model in 1D and seen the smaller sigma distributes the values, that is more concentrated to 0, and the larger sigma spreads more. So, more sigma approaches to uniform distribution. If I plot on the 2-dimensional this function using the color hot color map, then how this will look like. Gaussian filter, here there is, this is the code for Gaussian filter. So, then I am plotting this filter also. Here you can see that the middle one is the brightest and slowly it is reducing in 2-dimensional. This is the color intensity is varying as per the Gaussian model. This filter can be applied to any image. So, I am taking the number of padding on one side, then computing the Fourier transform of this, then convolving this with the input, and after convolution in frequency domain is multiplication. So, here multiply function is used instead of using convolution, and then after multiplication we need to do inverse Fourier transform, and then you will see you can show the image original image and resulting image here. So, I am using this plot comparison command, the function that we had defined in starting, where we can compare two images, G is the original image and f of hat is restored image. You can see the left side image is noisy image as compared to the right side image. So, the difference can be seen easily that restoration is working here. Next one is image inpainting. Image inpainting is the process of removing damage such as noises, strokes or text on the image. It is particularly useful in the restoration of old photographs which might have scratched or very old, having very much noise, they have ink spots, etc. This can be digitally removed through this method of restoration. From the images also, from the videos also you can remove the problems there by using restoration method. Image inpainting works by replacing the damaged pixel with the pixels similar to the neighboring ones, therefore making them inconscious and helping them blend with the background. There are many methods of image inpainting. Some modern applications use machine learning and deep learning methods also. In machine learning and deep learning based methods, there is no need to know about the problems details, all AI will take care, but in basic methods we need to provide prior information. Therefore, in order to remove black lines from the cat image, if I take one cat image as an example, we need to provide a mask that have the information regarding the location of the degradation and type of degradation. Here you can see an image of cat. What is wrong with this picture? What is the problem in this picture? The problem is that there are some black lines, unwanted lines. We need to remove these by using the image restoration method. So, here I am using OpenCV library for the restoration purpose, reading the image, then reading the mask, as I already told that mask is required for the location, then image inpaint filtering is to be applied to this, and you can see the output, all the black lines have been removed. Now, we can also, another use of image restoration is removing objects from the scene. Small objects or unwanted objects can be removed. So, here one logo, unnecessary logo is there in the image, that is need to be removed. We will create a mask, a set of masks that can erase the imprinting area. So, that when we want to remove an object from an image, we have either give manually delete the object, and if you manually delete the object, there will be white color, and if you remove this object with the help of image inpainting, the color will be as per the background. This is the Python code for this image inpainting. Again I am using the OpenCV library for the inpainting purpose. I am reading the image, then reading the mask or defining the mask, and then inpaint some biharmonic kind of inpainting method is used, and you can see that in the result there is no logo available. Here you can see by using the plot comparison command that I defined in the starting, that logo is removed. In this session, we have understood image restoration, degradation models, restoration of noise images, Gaussian degradation model, restoration of blurry images. And also we have covered a dented cat image using image inpainting. I removed unnecessary details available in the cat image. Also at the last I removed the logo from an image using image inpainting. You all can download the codes from my GitHub repository that is available at github.com/dratul/imagefilters. I hope you will explore some AI based method for image restoration. Thank you all. Happy coding. Meet you in the next tutorial.